So in today's class, we'll be looking at matrix plots and grid plots and how to do styling and coloring in Seaborn. Okay, and at the end, I will leave you guys with an exercise which you have to do as a homework. Okay, so we have already seen distribution plots and categorical plots in the first class of Seaborn and data visualization with Seaborn. Here we start with matrix plots. Okay, so matrix plot allows you to plot data as color encoded matrices and can also be used to indicate clusters within the data. Okay, so basically you can actually plot your data as a collection of rows and columns, just like a math notebook in our school days, and each cell is colored differently based on some property, right? Based on some row and column. So if it is my data set is about of students, then all my rows are every student and my columns are marks in all the main 5 subjects. Then each column, each cell is colored corresponding to the marks of that particular student in that particular subject, right? So it looks very beautiful, and it is very much understandable than a whole bunch of textual or just raw data. Okay, so we are working with Seaborn, so we will import the Seaborn as SNS, and we will do write this line to see the output or the plot in the output cell. And we will be working with an inbuilt data set called flights and also tips, right? So we have a variable called flights, which is a data frame and data frame of the data set flights, which comes by default with Seaborn. So we can do sns.load dataset, and I can just pass the name of the data set I want to work with. It is like installed, so it is in there in Seaborn. When you import this line, this data set also comes with it, right? Similarly, I store another data set which is called tips into a tips variable. So if I look at tips data set, it looks like this. It has these many columns. What is the total bill? What was the tip? What was the gender of the person who paid the bill, whether he was a smoker or not, what time of day, what day of week, what time of day, and what is the size. So it is basically a record, or you can say a data set from a restaurant where each row is a bill. So if suppose in the first row 2 people came and they paid a bill of around $17, they gave a tip of $1.1, and the female so the bill was paid by the female, right? They came on a Sunday, they did not smoke, and they came for dinner on Sunday. Like this person came with a group of 4 people, and she paid the bill. The bill was around $25. The tip was around $4, right? They also came for Sunday dinner, right? Like this is my
Yes.
every row is a customer. Next data set is the flights data set. Let's look at the first 5 rows of my data set. So it is year, month, and passenger. It's a very simple data frame. It is about travel the passengers traveling through flights for the 10 years from 1949 to 1960 in US, right? So like in which year, which month, how many passengers traveled? This year, this month, how many passengers traveled? Okay, and now we are looking at heat map. So in order for a heat map to work properly, your data should already be in a matrix form. Okay, so basically for making a heat map of anything, we need data in the matrix form. Matrix means my rows mean something, my columns mean something, and all the cells have a specific integer value, right? So for this January, February, March, or this female, male, dinner, Sunday, all this we cannot do a matrix plot. For only integer columns, I can do a matrix plot, right? So this is my tips data set. Now I want to so just to convert it into a matrix form, I can use this correlation method which we saw in pandas exercise. Okay, so tips dot correlation will give me the correlation of all the integer columns with each other. Okay, so it comes in a matrix form, right? So my rows are total bill, tip, and size. My column are total bill, tip, and size, and each cell has an integer value, right? So this integer value is showing me how much correlation two parameters have, right? So correlation can be like how much similar they think they are in behavior. Okay, so like your height and weight. So if a person's height is more, by default he's going to have more weight as compared to some other person of the same age but lesser height, right? Because he will have more bone and muscular material. Similarly, so if the number is closer to 1, it is very highly correlated. So for this column, total bill versus total bill, it's 1 because it has to be 1. So any one property, anything is completely related to itself, right? So if you are talking about, say, batting performance of Virat Kohli with you can say some other cricketer, so you can find some correlation based on their runs and how long they play and how like what is their style on different parameters. You can find some correlation. But what if you want to say what is the correlation of Virat Kohli's batting with Virat Kohli's batting? It has to be 1 because both are exactly the same thing. All right, next one is total bill versus tip. So the correlation is 0.67. That means there is a positive correlation of around 67%, right? So that means 60% of the time these are highly correlated, right? So basically if this value is close to 1 or -1, there is a very high positive correlation or negative correlation. If the correlation value is close to 0, that means there is no correlation, right? Just simple one mathematical formula. So now since it is in matrix form, I can just plot this thing by using a heat map, sns dot heat map, and I can pass this matrix as the argument. So I'll get a plot like this, right? So it is giving me all the columns with all the other columns, and on the right side we have this legend, like this color means, so this bright color means complete one correlation of 1, and the darker the color means the lesser the correlation. So I can clearly see that the diagonal is highly correlated, which is by default, and this red value is highly correlated. This black one is less correlation, right? Now you can change that style or the color scheme by of this heat map by passing a parameter called CMap. Previously we used to call this thing as palette. So different libraries have different nomenclature and have different keyword names, right? Essentially they do the same. Palette is also for coloring, CMap is also for coloring. CMap is used in SNS, palette was used in matplotlib. Okay, so CMap is cool bomb, it's a scheme, and annote is equal to true means I want, so whatever the value of each cell is, I want to write it there, annotation. Okay, so it will show the color and these values also, like what was the color, what was the correlation. So this kind of a plot is called a heat map. Okay, so it's why it's called a heat map, because it looks like, suppose like uh, so if you use a thermal camera, or if you get a thermal image of anything, so the complete picture you will get in some kinds of gradient, in some form of gradient in a color. So more red, very dark red, red, less red, bluish, right? So this kind of a color variation when it is used to display some third property, right? So this thing is called a heat map. So you can think of like if you burn this paper, so the depending on the color of the burnt space, I can say that this is highly burnt, this is less burnt, right? So you can make a correlation from there. Heat map is, that's why we call it a heat map. Right. Next, we look at this our flights data set. We are passing the 24 as the argument of the head method, which will give me, fetch me the first 24 rows of this data set. Right. So it looks like this. So first we have year, then we have month, then we have passengers. So one interesting thing to note is that like year remains same for up to like 12 values entries, because for month will keep changing. Then I will have values. So there is kind of, we can have a better representation of this data set in a pivot table, or in a way like this, where my all my rows are the different months and my columns are different years, and my cell value is the number of passengers traveled in that particular year in that particular month. Okay, it's very much easy to see this, right? So what will I use? I'll use a pivot table. So I'll use so what I want is, I want my values to be this column, passenger column. Let me just do this instead. Okay, leave it. So I want passengers to be my values, and I want my columns to be the year, and I want my month to be my rows. So I will use like this. Flights dot pivot table means convert this thing to pivot table, where value should be the passenger column, index or the row name should be the month, and column should be my year column, right? So I get a database like this. So it's now it is in a complete matrix form. I can actually plot it well using heat map, right? So for that I have to pass this whole thing as the argument to heat map, right? So I will store this in a separate variable called PV flights, or pivot table of flights. right? So same thing, I'm using just storing this in a variable, and I'm passing sns dot heat map. Inside this, I'm passing this thing, this variable. So I get a plot like this, right? So it is, I think you can understand based on this plot, there are some special things about this plot. Like this section is quite bright, this section is quite dark, the top half is quite dark, and it is increasing from left to right. See, the brightness is increasing from left to right. The rows are the year, and the columns are the year, and the month are the rows, right? So we can see that around 600 to 500 people traveled at this part of the plot, which means during the year from 1958 to 1960, lot of people traveled in the month of June, July, August, right? And we can, in general, we can see that year wise, in the year 1957 to 1960, these last 4 years, lot of people traveled on using flights as compared to initial days 10 years back. So the reason can be there are lesser flights in 1947. It's around 72 50, yeah, 72 years back in the history we are talking about. So there are not very much flights. So it's kind of a new emerging technology, and it was not considered safe. A lot of people feared to travel, but as the time passes, it became more common. Like people started traveling more often using flights. So that's why it is increasing. And why there is an increase where there is a higher number of passengers during the month of June, July, August. Can one can reason can be that this data set is from US, and during the month of June, July, August, they have summer vacation there, or you can say they have summers, right? So it's kind of a vacation period for everyone to travel, right? So this idea, by plotting just one line, I can get this much of idea from any data frame, right? So if I have shown you this plot, you will take around 20 minutes to 1 hour just to figure out what is the maximum number of passenger traveled, what is the trend, in which year people are traveling more, right? Like this is much easier, but here also will take some time, okay, to manually figure out, okay, which was the highest number of passengers, or what is the trend. But when I plot in this way, I get a very clear picture, right? So it has some heat maps, so have some parameters like CMap. We have seen we can provide a different color scheme and a line color. Suppose I want to provide lines in between these rows and columns, and I can provide a line width, right? So I get a plot like this where there is a separation between all the rows and columns, right? Next one is the cluster map. So cluster map is in any data frame, it will give you a cluster or a pair or a collection of values which are similar to each other based on the parameters, based on certain features, right? So you can see in the during the recess or in the interval, the students are moving in different groups based on their similarity. So they can belong to the same class, they belong to the same lab group, or they belong to the same bus, so they are going together. So this kind of clusters, like normally during the prayer time, you cannot see that cluster because everyone is arranged class wise, right? But during the interval or recess, you can see that, right? So I can have a cluster map by using SNS just cluster map, and I can pass the pivot table or the matrix, right? So this is what a cluster map looks like. Let me just zoom out a bit. So this is what a cluster map looks like. If you focus, you will find that the years are disarranged, starting from 1949, 50, 53, 54, 51, 52, and the name of months are also disarranged. They are not in any order. So basically, they are aligned in a way so that the values or the entities which are similar to each other are paired together. So if you look at this portion, these two are connected together. That means this row and this row are somewhat similar, right? And these two rows together are similar to these two rows together based on this diagram, right? So basically, it is kind of creating a hierarchy or a level of similarity between all the rows and columns. This thing is showing between rows, and this thing is showing between columns. So this whole thing is similar to this whole thing, like these all rows. And if you want to dig down, that means these two are similar to each other, because I can see the color scheme, the color is also kind of similar, right? So what do you mean by getting similarity here? So I can see like this whole row is similar to each other because it is equally black. Now I can say these two are similar to each other, these two are similar to each other because the trend is similar. So I can say that July and August month are almost similar for every year. So if you talk about year 1951, July, August are almost equally violet, right? And the trend is same. So there is kind of similarity between these 2 months, and I can say December and the January month are similar. See, this thing is pink, this thing is equally pink visually if I see. So this is because of number of similarities. So like in December, 432 people traveled, and in January, 417 people traveled. So it's kind of same. There is a difference of what, the 15, right? So this is how a similarity is calculated. So we can do it manually, but cluster map gives us clusters by itself. Currently, the values are varying, are the absolute values. It is going from 200 to 600. I can normalize these values in between 0 and 1 by using standard scale, right? So I can CMap Coolworm, same, it is the same plot. I'm just using a variable called, or keyword called standard scale. I'm putting it equal to 1, right? So it is now all my values are standardized between 0 and 1. So I get a plot like this. So here it is like much more clear. So these two are, are equally red. That means these two are similar. These two are actually very similar in the skin. They both have the skin color type of period. So they both are similar to each other, right? And these two are similar to these two based on this the data matrix that we created. Okay, so this is what a cluster map is, right? Now next we have to look at grids. Okay, so this was matrix plot. How can you plot matrix plots? And now next one is how can you plot some grids? Let me zoom in. Okay, so it's a new script. We are working with Seaborn, so I'll import all the libraries. So actually grids are a general type of plots that allow you to map plot types to rows and columns of a grid. This helps you to create similar plots separated by features. So grids is basically it's a way of creating the plots by yourself, right? So suppose you want to create a plot where my plot has 4 plots, one like 2 rows and 2 columns, and the top row has maybe that passengers has one feature, the second row has another feature, the first column has another feature, the second column has another feature. So I'm plotting 4 features in 4 plots in just one go. Okay, so I'll start with importing all the required libraries like Seaborn as SNS and matplotlib.pyplot as PLT. I'll do this line to see my plot in the output cell. So here we will be working with a very famous data set. You must have heard of it. It's called iris, and we are storing it in the iris variable. If I look at my data set, it looks like this. So iris data set is a data set of flowers, right? So there are 3 species of flowers which are classified based on sepal length, sepal width, petal length, and petal width, right? So every flower has a colorful petal and a green petal, right? So green petals are called sepal, and the green petals are called petals, and the colorful petals are called sepal, right? So this is what, so if this is the height and width of sepal, this is the height and width of petal, the speed is setosa, right? So this is the data set of this thing. Now let's look at what a pair grid is. So pair grid is a subplot for grid for plotting pairwise relationship in data set, right? So we saw joint plot and we saw pair plot where we can plot all the columns with respect to each other. So this is kind of a precursor, or you can say a more customizable form of pair grid. So if I do sns.pairgrid, it will give me a blank plot of all the rows with all the columns, sorry, all the columns with each other, right? So I get petal width, petal length, sepal width, sepal length, because these 4 are only integer, rest species is categorical. So I get all the integer columns with respect to each other in blank. So I can plot it any way I want. And now what can I do? Is I can see sns.pairgrid iris, right? And I can map anything. So pair grid will give me a blank canvas in this collection, rows and columns. Then I can map any kind of plot that I want to make on this. So I want to say g.map plt.scatter. So it will give me a scatter plot between all the columns with each other, right? So it will give me a scatter plot. Scatter plot is just whatever the value you do, make a dot there or make a circle there. It's a scatter plot, right? So I can see that petal length and petal width are kind of related. So if I increasing the petal length, the petal width is also increasing, right? So I see 2 clear groups here. So maybe this is one of the important reasons of classification. If the length is like, this can be a threshold. If length is below this, then this is a specific species. If length is above this, this can be a specific species. So it will be, we can look at this better in this way. And yeah, so currently we have plotted all the plots to be scatter plots, but we can also try out different plots like this. So I can create a grid, empty grid in this line. Then I can map the upper diagonal. Upper diagonal is my diagonal. Diagonal is this plot, this diagonal, right? So the diagonal should be histogram and map dot upper, or the upper triangle should be plt dot scatter and the lower triangle should be kde plot. So I'll get a plot like this. Diagonal should be histogram, diagonal is histogram, upper plot is scatter, these things are scatter, and these are kde plots or kernel density estimation plots. So it is just basically showing the same scatter plot in form of a density estimation, or like when it is very close. So like here, we previously here in this plot, we saw two different groups. So one distribution is here and one distribution is here. So same thing, if I plot using KD, it looks like this. So it shows two clear distributions, right? Now, if I do a pair plot, so we saw this earlier, pair plot will give me a pairwise plot of all the columns like this. Right now, here I can pass a third argument as hue. I want the species, and the color palette should be rainbow, right? So here I can give the parameter hue as species. So I'll get color. I can color all these scatter plots based on the species they belong to, right? So I can clearly see that in this plot, this blue thing is setosa, this central green part is versicolor, and this top right part is virginica, right? So based on petal length and petal width, I can clearly differentiate between the different types of flowers, right? So I can see the kind of distribution everywhere. Okay, so I'm sorry, I'm not able to show you this in a bigger way because the screen size is limited, right? Next one is the facet grid. Okay, so now facet grid is a general way to create grids of plot based off of a feature, right? So this is basically plotting petal length, sepal length with each other, right? All the columns are being plotted with each other. So what if I want to plot a specific column with a specific column, right? Some specific column I want to plot. So let's work with the old data set, right? Tips data set. It looks like this, and I'm creating a sns.facet grid. I'm naming all my plots as G. sns.facet grids. Make a facet grid or maybe an empty grid. On the tips data set, the column should be time and the rows should be smoker, right? So basically time is what? Time in my data set, time is mainly lunch and dinner. So I will have two columns, one for dinner, one for lunch, and I have two rows, one where the smoker is a smoker and there is a no smoker, right? So I can plot something on this plot like this, so it will give you a more meaningful idea, right? So SNS facet grid, same thing I'm making, and on this blank plot, I'm plotting g.map plt.histogram, make a histogram based on the total bill, right? So basically, and this plot is what I am getting. So I'm getting total plot. I have four different plots. This thing, this row, these two plots are both are for smokers. Smokers lunchtime, smokers dinner time. Then non-smoker lunchtime, non-smoker dinner time. And what we are plotting is the total bill. So what is the total bill for smokers in the lunchtime? This is the total bill. What is the total bill for smokers in the dinner time? And we can clearly see that the bill for smokers during the dinner is more than bill for smokers during the lunchtime, right? Now I want what is the bill for non-smokers in the lunchtime and what is the bill for non-smokers in the dinner time. So this is the distribution, right? So I can clearly see that non-smoker lunchtime bill is more than smoker lunchtime bill, right? Because this is more than this one. And this thing like smoker dinner time bill is more than non-smoker dinner time bill is more than smoker dinner time bill. Like this, the peak is higher, right? So this kind of distribution I can get. Another kind, if you want to plot, as suppose I'm plotting same thing, I'm making a facet grid of the tips data set. The column is time and the row is smoker and hue is sex, gender, right? So third parameter I'm also adding, and I'm plotting total bill and tip, right? And I'm also adding legends, right? Dot legend. So I'll get a plot like this. So So here there was only x-axis. I have data on the x-axis. Y-axis is nothing. Here I have on the x-axis I have total bill in each plot, and on the y-axis I have tip. And I am also getting information whether it was a male or a female, and I am also getting whether he was a smoker or not, smoker, non-smoker, lunchtime, dinner time. Right. So I'm getting multiple dimensions of information in just one plot. Okay, so I can see that total bill by for dinner by non-smokers is this much, and tip, like the relationship between total bill and tip is like this for non-smokers and dinner time, right? And I can see the males and female distribution too. So this is what the power of facet grid is. You can plot beautiful plots like these. Next, suppose I want to plot a joint grid. The joint grid is a general version of joint plot, right? So basically we saw joint plot where I can plot two columns. So if I give you joint, if you plot joint grid, it will look like this. Basically a blank canvas. What should be the X, what should be the Y, and what should be my tips. Now on this I can plot what kind of a plot I want. So I can say this is the same thing as above. On this plot, SNS reg plot, SNS distribution plot. So you plot these two things. So I'll get a regression plot, and I'll also get a distribution plot. So basically this is how a joint plot is made. So if you directly use joint plot, you will get this output, right? So this is about grids. Next, we look at styling and color. So basically, you can perform some kind of styling to your plots, right? So what kind of a background do you want? If you want, you can apply different themes. You can customize the ticks, x-axis, y-axis, all that you can customize, right? So let's import, because it's a new script. I import all the required libraries. I also import this dataset tips, right? And I can see sns.count plot of sex of this column. This is my count plot, right? It will give me the count of male and female in the data set tips. Now I want to set style to white. I can set the style to white. It will give me a white background, right? So if you run this line anywhere in your code, every code will be, your every plot will adhere or accept this theme. It's a style, just like you can select any theme in your mobile phone and any theme in your desktop. It's the same thing. You can set style to ticks. So see here, there are no ticks on the y-axis. Now I set style to ticks. I'll get ticks on the y-axis and ticks on the x-axis. This is a tick, right? Next, I can remove d-spine. I can do d-spine. D-spine means I'll want to remove this horizontal bar and this vertical bar, right? This is removed like this. So next I want to see d-spine the left thing also. So I want to d-spine this line also. I can do d-spine left is equal to true, which is by default it is false, right? So I can get a plot like this. Then I can change the size and aspect ratio using matplotlib. This we have seen in matplotlib, it remains same. So you can use plt.figure, you can pass figure size. So you can get a plot like this 2x3, 12x3 or 4x6, whatever is a plot type, right? Next I can do a lm plot, total bill type, and I can pass the size, I can pass the aspect ratio, I can pass the data from which you have to plot. So my plot will look like this, right? Next I want to scale and context, right? So I want to so basically, suppose I want to make this plot for a poster or a A3 page or a A4 page or a PPT, which will be shown on the big LCD, right? So I can set the context based on poster or whatever my requirement is. I can set the font scale and I can do a count plot. So I'll get a plot like this. Like it will not, even if you do too much zoom, it will not pixelate, right? Like this. Okay. So next, I think you can, if you want to look at more info on this topic, you can go to this page, right? And I guess I'm done for this for today's class. This is all what I have to discuss with with Seaborn, right? So next, I have an exercise for you people. You just have to keep it's kind of a question answer way. The answer part is left blank for you to write your code, right? So you have to like start with a Titanic data set. It is on Google also. It's quite famous. Everybody, like everyone who is starting their journey in data science, they work with this data set, right? So it will look like this. It's a data set from the Titanic ship. How many people survived? What was their gender? What was their passenger class? And what was the fare? Where do they embark from? Like source station, which class do they belong, right? So, and next you have to like keep answering this question. So you have to obtain this plot. What will you do? Write your code here, right? For getting this plot, what will what will you do? You have to write your code here. So if you write your code in this cell, this graph will be gone. So you better write this here in this cell so that you can always see. So you have to plot the histogram of the fair column in pink color, right? So it's simple only, just one line. Here you want to have a box plot of class with age, right? So we can simple sns.box plot, x is equal to class, y is equal to age, data is equal to Titanic. Simple, one line answer. Here, this is what a violin plot. So same thing, class versus age, everything will remain same. You will do sns dot violin plot instead of box plot, right? Next, in this question, you have to do a count plot. We have already seen this before, like twice already we have seen this plot. Now next you have to plot this thing, survived p class age group. So basically you have to make a heat map from all the integer columns. So how can you do? You can see titanic.corr, it is written over here. So first you have to find the correlation and you have to pass that sns.heatmap titanic.corr. You will get see, and the color scheme is cool warm, right? So if you want to get the same color, right? Next is you want to create a grid, facet grid like this, and you have to plot these two plots. It's simple only. So you guys go through it. Seaborn is done. We need one more class to complete data visualization. We will be looking at pandas data visualization, pandas enable data visualization. Okay. So I'll share all of these with you. Please go through them, go through the complete Seaborn lecture series, go through the matplotlib part. Then that pandas inbuilt visualization is very simple. It's exactly like what we did in matplotlib, or it's just that we do not need any extra library. It is just built in pandas, right? So thanks a lot. If you have any doubts, we can stay. Otherwise, I'll just share the recording with you. I'll share the notes with you. You guys can practice on your own. Okay.
Yes, sir.
Okay, sir.
Okay. Thanks a lot. See you on the next class. Bye bye.
Bye,
Thank
sir.
you, sir. Have a good day.
Yeah,
Have
you
a
too.
good day.
Bye bye.